On July 14, 2015, NASA's New Horizons spacecraft made a historic flyby of Pluto, becoming the first spacecraft to closely explore this distant dwarf planet. This event marked a major milestone in planetary science, as Pluto had remained a mysterious and poorly understood world since its discovery in 1930. The mission dramatically reshaped our understanding of Pluto and its moons, revealing a surprisingly active and complex world. In this in-depth exploration, we'll discuss what New Horizons discovered on Pluto, what it means for planetary science, and how it has reshaped our view of the solar system. New Horizons was launched on January 19, 2006, from Cape Canaveral aboard an Atlas V rocket. Traveling at an incredible speed of over 36,000 miles per hour, about 58,000 kilometers per hour, it was the fastest spacecraft ever launched at the time. The mission had one primary goal: to explore Pluto and the Kuiper Belt beyond. The journey to Pluto took nearly a decade. During that time, New Horizons used a gravity assist from Jupiter in 2007, shaving years off the travel time and giving scientists a chance to test the spacecraft's instruments. This maneuver also provided New Horizons with the opportunity to study Jupiter's magnetosphere, moons, and ring system, serving as a valuable dress rehearsal for its main mission. Pluto, orbiting nearly 3 billion miles from Earth, had long been the subject of scientific curiosity. It was reclassified from a planet to a dwarf planet in 2006, ironically the same year New Horizons launched. Yet many scientists still believed it held secrets that could unlock important clues about the formation of the outer solar system. On July 14, 2015, after 9.5 years in space, New Horizons reached its closest approach to Pluto, just 7,800 miles, 12,500 kilometers above the surface. The flyby lasted mere minutes, but it was enough to gather an enormous amount of data. Because of the vast distance between Pluto and Earth, it took over a year to downlink all the data collected during the encounter. What came back was astonishing. Pluto was not a frozen, dead rock as many had assumed. Instead, it was dynamic, geologically active, and full of surprises. One of the most iconic images captured by New Horizons was of a heart-shaped region on Pluto's surface. Officially named Tombor Regio, after Pluto's discoverer Clyde Tombor, this area is composed of nitrogen and methane ices. Within this region lies a vast plain known as Sputnik Planitia, a frozen basin that appears to be geologically young, possibly less than 10 million years old. Sputnik Planitia is free of impact craters, suggesting active resurfacing is occurring. The most stunning discovery? Towering ice mountains as high as 11,000 feet, 3,500 meters, made not of rock but of water ice, Pluto's bedrock. These mountains defy expectations because small bodies like Pluto were thought to be geologically inactive. New Horizons revealed strange polygonal patterns across Sputnik Planitia, resembling convection cells. Scientists believe the nitrogen ice here behaves like a very slow-moving glacier, possibly convecting due to heat from Pluto's interior. This was a shocking revelation because it meant Pluto might still be geologically active, despite its small size and frigid temperature. Additionally, there were signs of cryovolcanism, ice volcanoes. Two large mounds, Wright Mons and Picard Mons, could be ancient cryovolcanoes that once erupted water, ammonia, or methane. If true, this means Pluto might have, or once had, a subsurface ocean fueling this activity. Before the flyby, Pluto was known to have a thin atmosphere composed mostly of nitrogen, with traces of methane and carbon monoxide. But New Horizons provided the first close-up look, revealing a layered, hazy atmosphere extending over 100 miles, 160 kilometers. above the surface. These haze layers scatter sunlight, giving Pluto a blue-tinted sky. They also affect the surface, depositing tholins, complex organic molecules created when solar radiation interacts with methane. Tholins give Pluto its reddish hue and could potentially hint at prebiotic chemistry. Even more interesting, Pluto's atmosphere undergoes dramatic seasonal changes. Because of its elliptical orbit and axial tilt, Pluto's thin atmosphere can freeze and collapse onto the surface or sublimate back into gas depending on its distance from the Sun. This dynamic climate was unexpected for such a remote world. New Horizons didn't just study Pluto, it also provided close-up views of its 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon, Pluto's largest moon, is so big that the two bodies actually orbit a common center of mass located outside of Pluto itself. Charon's surface features include a massive canyon system, suggesting past tectonic activity, and a dark reddish area near the pole nicknamed Mordor Macula. The reddish coloring may result from material transferred from Pluto's escaping atmosphere, suggesting ongoing interaction between the two bodies. Charon also shows signs of cryovolcanism and possible past subsurface oceans. Hydra and Nix, the smaller moons, were found to be more reflective than expected, indicating surfaces composed of relatively pure water ice. Their chaotic orbits and strange shapes suggested they were likely formed during a massive impact event that created Pluto and Charon as a double system. What makes Pluto even more fascinating is the variety of terrain observed. New Horizons imaged towering cliffs, possible ancient river channels, dark pits, and ridge networks, many of which remain poorly understood. The dwarf planet displays evidence of tectonic forces, glacial flows, and erosion by volatile ices like methane and nitrogen. Some regions appear older, marked with many craters, while others are younger and smoother. This patchwork of old and new terrain indicates Pluto has had a complex geological history, defying previous assumptions of it being a static world. Perhaps the most intriguing discovery is the evidence suggesting Pluto might harbor a subsurface ocean. Gravity anomalies beneath Sputnik Planitia and the lack of expected compressional features in the surrounding crust hint that there could be a layer of liquid water deep beneath the surface. Such an ocean would need antifreeze compounds like ammonia to remain liquid in the frigid outer solar system. If true, this places Pluto among the ranks of icy moons like Europa and Enceladus as possible abodes for life, or at least environments where prebiotic chemistry could take place. After Pluto, New Horizons continued its mission into the Kuiper Belt, a vast region beyond Neptune filled with icy bodies. In 2019, it performed a flyby of a small object now known as Arakoth, formerly 2014 MU69. Arakoth is a contact binary, two lobes that gently merged, and offers a window into the early solar system, as it likely formed in the solar nebula and remained unchanged for billions of years. This extended mission gives New Horizons the opportunity to explore other Kuiper Belt objects and study the interstellar medium. It continues to send back data, broadening our understanding of the outer solar system. New Horizons didn't just rewrite textbooks, it also reignited public fascination with space exploration. The stunning images of Pluto's heart-shaped plain captured hearts and imaginations around the world. The mission demonstrated that even small, distant worlds could be rich, dynamic, and full of surprises. In terms of science, New Horizons changed the way we think about planetary activity. Before 2015, geological activity was thought to require large planets or tidal heating from nearby massive bodies. Pluto showed that even small, distant worlds can be complex and active. The mission also reminded us of the power of exploration. Traveling over 3 billion miles through the solar system to study a world we had never seen clearly was a monumental human achievement, one that will inspire future missions to the outer reaches of our cosmic neighborhood. New Horizons revealed Pluto to be a world of breathtaking complexity, geological activity, and scientific intrigue. It shattered old stereotypes and opened new frontiers for planetary science. Far from being a frozen relic, Pluto is a dynamic world with its own story to tell, a story that continues to unfold. As we look further into the Kuiper Belt and beyond, the legacy of New Horizons will guide our curiosity. What else is waiting in the outer solar system? What other secrets lie hidden in the cold, dark corners of space? Thanks to New Horizons, we now know that even the smallest worlds can hold the biggest surprises.